Good morning, student. Today we are talk about our lesson combustion and flame. So yesterday we see exercise of this lesson. So today we continue our questions number 5. Give reason. That the third reason is third question. Is paper by itself catch fire easily, whereas a piece of paper wrapped around an aluminium pipe does not. So here the solution of this question are the paper by itself catches fire easily because of its low ignition temperature. Any material can catch fire when it goes to their ignition temperature. So in a case of paper, the paper by itself catches fire easily because of its low ignition temperature. Any material have a low ignition temperature, it's catch fire easily as compared to the high ignition temperature. The piece of paper wrapped around an aluminum pipe doesn't catch a fire because aluminum is a good conductor of electricity. So any piece of paper wrap around the aluminum pipe, it does not catch fire because aluminum is a good conductor of electricity. It passes the electricity from through the material. That material is the aluminum. When any piece of paper are wrapped around the aluminum, that aluminum are travel the heat and energy. So here our energy is electricity. So electricity is travel from aluminum to paper. That's why aluminum pipe doesn't catch fire. While the paper wrap around the aluminum pipe, result is an increase in ignition temperature. When the paper wrap around the aluminum pipe, it's increase the ignition temperature. That's why there is a transfer of heat from paper to aluminum pipe. Hence, it doesn't catch fire. So here, heat is transferred from paper to the aluminum pipe. That's why it doesn't catch fire. Next question. Make the label diagram. Make the label diagram of candle flame. So here you have to given that the label diagram. So you can draw the diagram and correctly label it. Here this is a diagram of flame and it's a correct labeling of this diagram. So now you can draw the diagram with the correct label. In this diagram, three zones are present in the flame. First is outer zone, second middle zone, and third is inner zone. So inner zone is a least hot, medium zone is a moderately hot, and the hottest part is outer zone part. So this is the wax candle. It's a burning flame. So the color of innermost zone of the flame is a black, middle zone is a partial combustion, that's why the color is changed into the yellow, and outer zone is a complete. During the complete combustion, its color gets changed into the blue in color. So now you can draw this picture with the correct labeling. Next question is, name the units in which the calorific value of a fuel is expressed. So here, what is a calorific value? Calorific value is defined as the energy. Here we have to given heat energy and light energy. So the energy contained in the fuel It is expressed in the form of kilojoules per kg. So here kg, its full form is a kilojoules, and kj it's a kilojoules, and kg it's a kilogram. You can use as a kg, kj or a kg. So calorific value is defined as the energy contained in the fuel. It is expressed, that value is a calorific value, and that value is expressed in the form of kilojoule or per kg. Next question. Express how CO2 able to control fire. The solution of this question is CO2 is a non-combustible gas. CO2 is a non-combustible gas. It is not completely combustible. So it's a non-combustible gas, and it's extinguish fire into two-way. That's why it's used as a fire extinguisher. So it is a heavier than oxygen. Carbon dioxide gas is a heavier than oxygen gas. It is cover the fire like a blanket. It cover any fire area. It's easily cover up like a blanket. Cut off the contact between the oxygen and fuel. When any fuel is contact with the oxygen, it's easily start to combustion. It's easily start catch fire. So in a case of, if any carbon dioxide cover are easily break the contact between, cut the contact between oxygen and fuel material. Next way is a, in cylinder CO2 is a kept in a liquid form. In cylinder, extinguisher cylinder, you have to see in your school and other areas like a hospital. So in this area you can see the cylinder, fire extinguisher cylinder. In this cylinder, the CO2 gas, it meant to say that carbon dioxide gas, is kept in the liquid form. When released, it expands enormously. It's easily cover the every area. That area is catch fire. This brings down the temperature of the fuel. It's actually work it, and it's bring down the temperature of the fuel, which help to controlling the fire. And CO2, it's help to control fire. That is the reason in the cylinder CO2 is used. Next question. It's difficult. It's difficult to burn and heap of green leaves, but a dry leaves catch fire easily. Here, the answer of this question is, the heap of green leaves contain a lot of moisture. Hence, its ignition temperature is high. Therefore, it does not catch fire easily, because that the heap of green leaves is contained a lot of moisture. Because of moisture, it does not catch fire easily. But dry leaves has a no moisture content in it. That's why the ignition temperature is getting low, and that's why that dry leaves is easily catch fire. So here it's a difficult to burn heap of green leaves, but a dry leaves catch fire easily. Next question. Which zone of a flame does a goldsmith use for a melting gold and a silver? Why? The goldsmith mainly use non-luminous flame. Non-luminous flame is mainly used a goldsmiths. It's termed to be outermost part of the flame. This part of flame is used because outermost flame undergoes the complete combustion, considered as the hottest part of the flame. Goldsmiths are mainly used as a non-luminous flame. So that part is a bluish color part. It's the outermost zone of the flame. That outermost zone of the flame, the temperature of this part is a totally high. That's why the gold and silver, it's easily get melted. So that outermost zone of the flame does the goldsmith use for the melting gold and a silver, because the temperature of this part is more hotter, more high. Next, it's a numerical. In an experiment, 4.5 kg of a fuel was completely burned. In our experiment, we have to given fuel. So 4.5 kilo fuel is completely burned. The heat of produce was measured. So here the producing of heat is a 1,80,000 kilojoules heat is produced from the complete burning of 4.5 kg fuel. Calculate the calorific value of this fuel. So we have to given for the weight of fuel. So we have to given the weight of fuel is a 4 kg. From this fuel we have to given the heat. That heat is a 1,18,000 joule. So here you have to write down in the solution. Next, therefore the heat produced by the first, we talk about 1 kg fuel. So heat produced by 1 kg fuel is a given heat energy divided by weight of fuel into 1. So it's only for 1 kg. So here the formula we will get kilojoule. It means to say that it's a calorific. It means to say that the it's the heat produces is a 1,18,000 divided by 4.5 kg into 1. So from this formula, using formula, we get the value for 1 kg fuel is a 14,000 kilojoule per kg. Hence the calorific value of fuel is a 14,000 kilojoule. So हमें जो हमारे एक्सपेरिमेंट में जो फ्यूल है वो 4.5 kg दिया है, तो पहले हमें जो मिला है वो लिख देना है. तो सबसे पहले वी हैव टू गिवन 4.5 kg फ्यूल. 4.5 kg फ्यूल के कंप्लीट बर्निंग से हमें हीट एनर्जी मिलती है. कितने अमाउंट में हीट मिलती है, तो वो हमें दिया है 1,18,000 किलो जूल हीट एनर्जी प्रोड्यूस हुई है. तो सबसे पहले हमें 4.5 kg फ्यूल के लिए 1,18,000 किलो जूल हीट मेज़र हुई है, बट 1 kg फ्यूल के लिए कितनी हीट एनर्जी प्रोड्यूस हुई है वो हमें यहाँ पर फाइंड आउट करना है. तो देयरफॉर हीट प्रोड्यूस बाय 1 kg ऑफ फ्यूल. तो सबसे पहले हमें जो हीट एनर्जी मिली है, सो यहाँ पर हमें लिखना है 1 kg ऑफ फ्यूल इज इक्वल्स टू जितनी एनर्जी मिली है, हमें हीट मिली है वो कितने हैं 1,18,000. उसे हमें उसके वेट से डिवाइड करना है. हमें कितने वेट से फ्यूल के बर्निंग से मिली है उतनी एनर्जी, तो हमें मिली है 4.5 kg ऑफ फ्यूल से उतनी एनर्जी मिली है. तो पहले हमें जितनी हीट है उससे हमें उसके वेट से डिवाइड करना है और मिले हुए आंसर को 1 से मल्टीप्लाई करना है. तो 4.5 को 1,18,000 से अगर हम डिवाइड करते हैं तो हमें आंसर मिलता है 14,000 किलो जूल पर केजी. तो 14,000 किलो जूल पर केजी ये हीट एनर्जी कितने केजी फ्यूल के लिए यूज़ हुई है, तो 14,000 किलो जूल हीट एनर्जी हमें 1 kg ऑफ फ्यूल से मिली है के लिए है. तो यहाँ पर जो हमें कैलोरीफिक वैल्यू मिली है, इट्स ए यूनिट मीन्स 1. सो हियर द कैलोरीफिक वैल्यू of the fuel of 1 kg fuel is a 14,000 kilojoule per kg heat produced by 1 kg fuel. So here we can calculate 11 example. So now from from question 5 to question 11. All question and answer you can write down your notebook.